Mysterious music plays softly in the shadowy corridors where scientific certainty meets the unknown. There exists a peculiar tradition, a ritual where the greatest minds of our species don't merely debate their theories. They wager on them. Welcome to the enigmatic world of scientific bets and challenges, where knowledge itself becomes the ultimate currency. I'm your guide into this labyrinth of intellectual gambles, where the stakes aren't measured in mere money, but in the fundamental understanding of our universe. What compels a scientist to stake their reputation on the uncertain? What whispers of confidence or doubt drive them to transform theoretical disputes into concrete wagers? These questions draw us into the mysterious psychology of scientific certainty. Throughout history, when words and equations proved insufficient to resolve the most perplexing disputes, scientists have turned to a more primal resolution: the wager. These bets reveal something profoundly human lurking beneath the cold façade of scientific objectivity, a willingness to put one's intellectual pride at risk in the pursuit of truth. As we journey through the most captivating scientific bets in history, we'll discover how these wagers have often accelerated discovery more effectively than conventional research. For in science, as in gambling, sometimes the most significant revelations come when someone is willing to push all their chips to the center of the table. Our exploration begins with perhaps the most consequential wager in intellectual history, one that, though not strictly scientific, set the template for all future scientific betting. In the 17th century, Blaise Pascal proposed his famous wager regarding the existence of God, a mathematical approach to faith that fundamentally altered how we conceptualize decision-making under uncertainty. Pascal's innovation was applying probability theory to metaphysical questions, suggesting that when facing the unknowable, we must calculate expected values of our beliefs. This framework would later become the foundation for scientific wagers, where participants must quantify their certainty in otherwise abstract theories. What makes Pascal's approach so bewitching is how it transforms the intangible into the measurable, a philosophical sleight of hand that scientists would adopt whenever venturing into realms where empirical evidence remained elusive. No scientific disagreement has generated more fascinating wagers than the decades-long intellectual duel between Albert Einstein and Niels Bohr over the nature of quantum reality. Their debates at the Solvay conferences have achieved mythological status, but less known are the series of thought experiment challenges that Einstein continually issued to undermine quantum theory. God does not play dice with the universe, Einstein famously proclaimed, to which Bohr enigmatically replied, "Einstein, stop telling God what to do." Behind this theatrical exchange lay a profound wager about reality itself, whether the universe operates according to strict causality or whether indeterminism lurks at its foundation. Einstein repeatedly devised ingenious thought experiments attempting to reveal contradictions in quantum theory, essentially betting his scientific legacy that Bohr's interpretation would eventually collapse. Each time, Bohr would dissect Einstein's challenge, discovering subtle errors that preserved quantum weirdness. This intellectual chess match, spanning decades, represents perhaps the most profound scientific bet ever made, with reality itself as the stakes. In 1997, cosmic gambling reached new heights when Stephen Hawking conceded what he called the most sensible bet I ever lost. For nearly 3 decades, Hawking had wagered with fellow physicists Kip Thorne and John Preskill over the fate of information swallowed by black holes. Hawking had bet that information falling into black holes vanishes from our universe forever, a position that, if true, would undermine fundamental principles of quantum physics. The stakes: a subscription to Penthouse magazine for Thorne versus an encyclopedia for Preskill if Hawking lost. What makes this wager so captivating is how it encapsulates a genuine paradox in our understanding of physical law. If information is truly destroyed in black holes, quantum mechanics breaks down. If preserved, general relativity suffers. The resolution remains one of physics' most beguiling mysteries, with Hawking eventually conceding the bet but leaving the deeper puzzle unsolved. A reminder that sometimes even losing a scientific wager can illuminate the boundaries of human knowledge. Perhaps no scientific challenge faced more entrenched resistance than Alfred Wegener's theory of continental drift. Though not structured as a formal bet, Wegener essentially wagered his scientific reputation against the entire geological establishment when he proposed in 1912 that continents move across Earth's surface. The geological community responded with unprecedented scorn. One critic wrote that pursuing Wegener's theory was to play with a theory as with a toy. Another called it Germanic pseudoscience. Wegener died in 1930 during an expedition to Greenland, his theory still widely rejected. Yet the most mysterious aspect of this scientific challenge was yet to unfold. Decades after his death, evidence from paleomagnetism, seafloor spreading, and plate tectonics vindicated Wegener completely. His posthumous victory in this unspoken wager reminds us of science's most enigmatic quality. That truth often emerges regardless of contemporary consensus, patiently waiting for technology to catch up with intuition. In 1980, economist Julian Simon issued a peculiar challenge to biologist Paul Ehrlich, who had predicted imminent resource depletion and global famine in his bestseller, The Population Bomb. Simon, skeptical of these doomsday forecasts, proposed a wager. Ehrlich could select any 5 raw materials, and they would track their prices over 10 years. If the inflation-adjusted prices increased, suggesting growing scarcity as Ehrlich predicted, Simon would pay the difference. If prices fell, suggesting increasing abundance despite population growth, Ehrlich would pay. Ehrlich confidently selected chromium, copper, nickel, tin, and tungsten. When the decade concluded, all 5 materials had fallen in price, some by over 50%. Ehrlich sent Simon a check for $576.07 with no accompanying note, having lost what became known as the bet among economists and environmentalists. What makes this wager so captivating is how it transformed abstract economic and environmental theories into a quantifiable prediction, demonstrating the clarifying power of scientific betting in fields where rhetoric often obscures measurable outcomes. Not all scientific wagers resolve quickly, some stretch across centuries, outliving generations of scientists. None better illustrates this than Fermat's last theorem, which began in 1637 when Pierre de Fermat scribbled in a book margin that he had discovered a truly marvelous proof, but the margin was too narrow to contain it. This cryptic note launched a 358-year mathematical quest. Fermat had essentially placed a bet with future mathematicians, challenging them to rediscover his proof. The greatest minds in mathematics, including Euler, Gauss, and Riemann, attempted to win this wager against a dead man. The challenge would remain unresolved until 1994, when Andrew Wiles finally provided a proof using mathematical techniques that hadn't existed in Fermat's time, raising the tantalizing question of whether Fermat had actually possessed a valid proof or had been bluffing all along. This century-spanning bet reminds us that scientific challenges sometimes require waiting for entirely new frameworks of thought to emerge before resolution becomes possible. Perhaps no scientific wager has had more profound philosophical implications than the series of bets surrounding quantum entanglement. Einstein, deeply troubled by what he called spooky action at a distance, essentially bet his conceptual legacy on the impossibility of quantum theory's strangest prediction, that particles can instantaneously influence each other regardless of distance. In 1935, Einstein, along with Podolsky and Rosen, published a thought experiment intended to demonstrate quantum theory's incompleteness. The implied wager was clear. Either quantum mechanics was wrong, or locality and realism, principles Einstein considered indispensable, would have to be abandoned. Decades later, John Bell developed a mathematical inequality that transformed this philosophical debate into a testable prediction. When physicists like Elaine Aspect performed the experiments in the 1980s, the results were unequivocal. Einstein had lost his bet against quantum weirdness. Entanglement was real. This wager's resolution fundamentally altered our conception of reality itself, demonstrating how scientific bets often clarify not just specific theories, but the philosophical foundations upon which science itself rests. In the realm of theoretical computer science lurks perhaps the most financially significant bet in scientific history, the P versus NP problem. This mathematical question asks whether problems whose solutions can be quickly verified can also be quickly solved. The stakes of this particular challenge were formalized in 2000, when the Clay Mathematics Institute offered a $1 prize for its resolution, essentially placing a seven-figure bet on the importance of this abstract question. What makes this wager particularly bewitching is its practical implications. If P equals NP, encryption systems protecting everything from banking to national security would immediately become vulnerable. Proofs of mathematical theorems that might take centuries could be generated automatically. The problem remains unresolved, with most mathematicians betting that P does not equal NP. Yet this consensus lacks definitive proof, a reminder that at science's frontiers, even collective certainty must sometimes be quantified through formal wagers against the unknown. The tradition of scientific betting continues into the modern era, now formalized through platforms like the Long Now Foundation's Long Bets project. Here, scientists and futurists place public wagers on predictions ranging from climate change outcomes to artificial intelligence capabilities, each bet backed by arguments that must stand the test of time. What distinguishes these modern wagers is their increasingly public nature. Where Einstein and Bohr once debated privately at conferences, today's scientific bets unfold under public scrutiny, transforming abstruse scientific disagreements into accessible narratives of competing visions. Climate scientist James Annan has won multiple bets against climate change skeptics, while AI researchers regularly wager on milestones like machine mastery of specific games or capabilities. Each bet creates a moment of clarity in fields often clouded by complexity and politics, distilling years of research into testable predictions with definite resolution dates. As our exploration of scientific wagers concludes, we're left with a profound realization. These bets reveal the true nature of scientific progress more honestly than textbook accounts. Science advances not just through dispassionate analysis of evidence, but through the very human willingness to stake one's intellectual reputation on uncertain outcomes. The greatest scientific bets teach us that certainty and uncertainty exist not as opposites, but as complementary forces driving discovery. When scientists are most certain, they should be willing to bet on their theories. When most uncertain, a well-structured wager can illuminate the path forward more clearly than any experiment. Perhaps most mysterious of all is how these wagers transform abstract theories into concrete predictions, forcing precision where ambiguity might otherwise persist. In the end, the most valuable currency in science isn't data or equations, but the willingness to bet on one's conviction while remaining open to losing. For in that paradoxical space between confidence and humility, we find science's true power, the capacity to be wrong in the service of eventually being right. Until next time, remember that the universe's greatest mysteries often resolve themselves when someone is willing to place the right bet. Mysterious music fades out.